Hey, welcome. Welcome to the sixth lecture in the Design of Embedded and Intelligent Systems course. Do you have some coffee? I hope so. As you can see today, I've got an avatar that I'm using. And we will be talking about implementation and software. So first, I'll talk a little bit about working with data in general, then we'll talk about the course project. So how can we work with data on computers? Computers use binary, humans usually use maybe decimal to talk about numbers, but there's other bases as well, like octal and hexadecimal. Hexadecimal is easy to change into binary, but it's easier for humans to read, so it's sort of a compromise. So if we have 2 in decimal, then this would be 1, 0 in binary. And how do we get there? Well, we can see that this first 1 is multiplied by 2 to the first, and then you add 0 times 2 to this 0. And that's the same for all bases. That's how it's encoded. So like, for example, for decimal, then it would be times 10 to the 1 or times 10 to the 0. Least significant bit, most significant bit for bits and bytes. So this is the most significant bit. This is the least significant bit because it encodes for a lower value. This is the most significant byte. This is the least significant byte. And there's orders in which data are stored or sent. This is like serialization stuff. One order is called big endian, and this means that the big end, the biggest byte is stored in the lowest memory location, so it's stored first. So for example, here, if we have this string over here, then the most significant byte would be stored first. In little endian, however, the least significant byte is stored first. In networks, big endian was common. In Intel microprocessors, little was popular. The next thing then is computers work with data that way, but how do we work with data then as programmers? We use programming languages. In this course, you're free to take whatever languages you want to use. However, we usually use Python and C++ with ROS2, and we also use a C++ language for Arduino microcontrollers. Other than that, everything's free. Bash is very useful for you if you're using Linux and Ubuntu. This is the default for the command line, so these commands are useful. C++ and Python I mentioned are very useful. C++ is very fast, but you have to compile. Python is a little bit slower, but you don't have to compile, which is awesome. And then there's many similar languages to C and Python. You have sort of more strange languages like Prolog, which is quite versatile also. In that if you program it to answer one thing, you can also get maybe other answers as well. SQL is very useful for databases. Scheme Lisp is a functional language or functional languages. Assembler is a little bit more work, but the result, you can create really fast, small code. XML, JSON, data interchange languages. Erlang is a distributed language. VHDL is for defining hardware. So here are some nice bash commands. I won't go into this. This is a reference for people who are interested. C++, I mentioned, is quite useful. People tend to be a little bit afraid about compiling, linking with C++. And in fact, there are many ways to do this, but it can actually also be really simple. If you just type in G++ and then some file, you can get an executable from that. Python, I mentioned, is really useful. And you can see small differences with C, like, you're not using semicolons, you're using spacing instead of braces to structure your code, and elif instead of else if. Lots of other languages that are very similar from the programming side, like Java or C#, JavaScript, MATLAB, R, Swift, Go, Objective-C. R is good for statistics. Simulink, the automotive industry seems to like Simulink quite a bit. MATLAB, though, is not open source. You have to pay money to buy it. Prolog, here's an example of Prolog. and an example of SQL, an example of list scheme. So you can see that you use really lots of parentheses. Assembler, you can see it's quite a giant amount of code just to do hello world. Basically, you're manipulating registers and calling interrupts. Data interchange languages, XML is really well known, I think. JSON has become popular in recent years because it's a little bit less verbose and you can parse it faster. VHDL is a way to define hardware. Erlang is used for distributed systems. And BASIC is a little bit interesting. It was created to be sort of user-friendly, but it did have some features that people didn't like so much, like the go-to statement, for example, which some people thought wasn't good coding style. Okay, let's have a little quiz. So if you want, you can go ahead and pause your video. Otherwise, we'll go and answer this. So the first one, I assume you've paused. This one is, what is it? It's assembler. This one is C++. This is Prolog. This is Lisp, Scheme. This one is Python, MATLAB, Java, and Bash. Okay, so next we'll talk a little bit about databases. Why databases? These are good for robot brains because with embedded and intelligent systems, often we're dealing with really lots of data. And at Halmstad University, our smart home also uses a database as its brain because of this. In recent years, relational databases were very popular, which can be queried with SQL. And they have these ACID guarantees, so atomicity, all or nothing, consistency, transactions must meet all rules, isolation, transactions which occur concurrently are treated as if they're sequential, durability. The database is recorded in a non-volatile way so that even if you lose power, you'll still have your database. When the internet became very popular, then a problem emerged called the object relational impedance mismatch. So basically, relational databases weren't so great for objects like web pages and videos, where they wanted something a little bit more simple, that's more scalable and fast. And so no SQL was proposed for this. And then in recent years, though, there was another thought that we really do want ACID and to be able to use SQL. So new SQL was proposed, which combines both of these nice aspects, relational ACID plus scalability and speed. Next we'll talk about your project. So you're going to use an Arduino microcontroller in your project. What is that? It's a small computer, which is quite popular and easy to use. And when you start programming Arduino, you'll notice that your programs tend to have two functions, setup and loop. Setup is run once and then loop will, as the name says, loop repeatedly. Your hello world example for Arduino is called Blink. You can open it under examples 1 basics Blink. And when you do that, you'll see an LED blinking, which is really, I really suggest that you try that if you haven't worked with Arduino before. The next step after you can program your Arduino is to be able to talk to it through your own programs. So a few years ago, I coded this in Python, this very short, simple program that just sends a byte over to your Arduino. You just should note that if you're not using an Arduino Uno, then maybe this string will change that you're accessing. You also have to make sure the baud rate is the same in your program and Arduino. And also you can try something very simple at the start, like just toggling an LED on and off. You will also use Robot Operating System in this course for your project. And what is it? It's a framework with some helpful tools for robots. And the big thing is basically that it allows code reuse. The downsides, it might require Linux. It's not intuitive. It requires quite a bit of learning. Yeah. So ROS1 versus ROS2. In this course, we use currently ROS2. And I think it's important to warn you that ROS1 and ROS2 are quite different. It's not just an extension. They've got completely different commands and different technologies they use. For example, ROS1 uses a custom middleware for different things, and ROS2 it's abstract, so you can slip in different things, different middlewares that you like. Currently, it's using data distribution service. If you want to communicate between ROS1 and ROS2, you can do that using a bridge. But ROS2 is a little bit more current, so Python 3, more recent C++, and you don't need a master, which is nice. ROS concepts, okay. So a node is a running program, a package is a group of files, and you work with that in your workspace. There's a file in your home directory called .bashrc with some important variables that you can set there. If you want to source stuff, you can do it there. One of the main concepts in ROS is asynchronous callbacks. The idea is that you've got a robot which is running lots of different things all at once. Maybe it's a laser scan, it's listening for humans to do something. And so basically what happens is that you get events, and when you get these events, like a human says something, then you can act on it. So the publisher, subscriber, and service client are two common patterns there. There's also a lot of useful software that's related to ROS. One is RViz for visualization, one is Gazebo as a simulator, and one is MoveIt for motion planning. So if you have a big humanoid robot and you want it to move its arms, MoveIt can be quite useful. There's lots of important commands in ROS2. I've listed some of them, basically how to compile and build stuff, how to see what topics your robots are listening to and publishing to. Yeah, and the ROS2 run and ROS2 launch are also very important. ROS2 run will run one node. Often you've got lots of nodes and it becomes a hassle to do each one in a separate terminal all the time. So you can just call ROS2 launch, make yourself a launch file and just run it once, and then all the nodes will start up. Then I've got some tips for setting up your .bashrc file. Messages are a big thing in ROS. So for example, this is a motion command, motion command message called geometry messages message twist. If your program isn't working, you want to debug, you can send a command through just the command line interface as shown at the bottom of this slide, which is using this YAML format. I've written two Hello World programs, one in Python, one in C++. For ROS2, you can see the Python one here. There's nothing terribly interesting that's happening here. You initialize and you create a node, and then you output something to the screen, and then you're spinning. So in ROS, this is common. You spin, and then when you get events, you process that, and then you clean up afterwards. Same thing for the C++ example, initialize, spin, and at the end shut down. Let's have a little quiz. So if you want, pause your video, otherwise go ahead. So what happens if you're caught working on a database with ACID? Oh my, you might actually be complimented, because ACID with databases is a good thing. What functions are typically included in an Arduino program? Set up in loop, as we discussed. What is a typical way to pass messages? Publish and subscribe. That means if some robot publishes some message, everybody who's subscribed to that topic will get the message. If you want something where you get a handshake type thing, where you send a robot a command and you want to know that it's actually heard you and carried out the command successfully, you should use service client, the service client pattern. Thank you for listening, and if you want to hear a bit of trivia, please stick around. So I took my PhD in Japan. I think it's really an interesting country with interesting culture. What do you think this moving stuff is that you just saw? So you can see on this plate of food that this stuff, this thin stuff at the top is moving around. The answer is it's fermented fish. It's katsuobushi. So it's basically, you can call it bonito flakes. It's dried, fermented, smoked fish that you shave down and put on food. What food is being fried in the middle of the grill in the video on the left, the lower left? This is tripe, it's intestines. You eat a lot of intestines in Japan when you fry meat. It's very good. How can one write the name of the delicacy on the lower right, favored in the western part of Japan? The answer is river pig. It is blowfish, which can be a little bit dangerous if it's not processed correctly because it has tetrodotoxin in it. Weddings. What do the bride and groom drink at a Japanese wedding? The answer is sake. Yay. What is the big thing on the bride's head supposed to do? The answer is A, hide her horns. D, it was also interesting to me, great place to put your snacks, but it's actually very heavy, so you don't want to put your snacks there. You should put them maybe in somewhere else. Okay, that's it for today. See you guys.